So in this video, we are going to be looking at order of operation of arithmetic, problems. So what we are going to be looking at here is the BODMAS. Well, someone may say this is an old, method. Yes, it's old, but it is still valid. This BODMAS is the same thing that is being called what? PEDMAS, right? PEDMAS implies that you are taking the operation from the left, to the right. So what does B represent? B represent bracket as I have written it here, which means parentheses, right? O means order. Order of operation here means that you are going to prioritize the exponent. When I say exponent, that these are the terms of that particular problem that carries power, right? Like a raised to power x, square root of a, cube root of a, then followed by division, multiplication, addition, and subtraction. But all of these are done from what? From left, to what? To right. So this needs to be, one has to be very careful. From left to right, that's what I've put here. So the question is, how do we apply this particular order of operation? Let's look at this example. This example says simplify 10 whole number 2 over 5 minus 6 whole number 2 over 3 plus 3. Now if you look at this is a combination of minus, that's subtraction, and addition, and under the BODMAS rule, PEDMAS, addition and subtraction, you can evaluate them together. But when it comes to division and multiplication, you have to prioritize division before multiplication, as long as you are using the BODMAS or PEDMAS rule. So now let's simplify this. The first thing we need to do is to first take this from a mixed fraction. This is a mixed fraction. We take it to its improper fraction equivalent. So 5 times 10, that is 50, plus 2. That is what? 52. This will give us 52 over 5. Then minus 3 times 6, 18. Then 18 plus 2. That is what? 20. So this will be what? 20 over 3. Then plus, this is 3. In reality, it's actually 3 over 1 because the denominator is 1. The next thing we need to look out for is the lowest common multiple of these three terms. So what will be the lowest common multiple? We draw a line like this. The lowest common multiple is you considering the two common terms here. That is 5 times 3. That's the best and easiest way. Basically, we are looking for a term that will go in all of them, so we can use 15. That's 5 times 3. That is 15. Or perhaps somebody is looking at it, how do I get 15? Okay, let's quickly draw a small table here to find the lowest common multiple of what? 5, 3, and what? And 1. So 5 in 5, that is 1. 5 in 3 is not possible, you return the 3. Then 5 in 1 is not possible, you return 1. The next thing is what's 3? 3 in 1 is not possible, you return 1. 3 in 3, that is 1. And 3 in 1 is not possible, you return 1. So the next one is what? 1. 1 in 1, 1, 1, 1. So if you want to find the LCM, that is what? 5 times 3 times 1. That will give you what? 15. Though this I'm just showing you, so there are other ways that one can find the LCM. So the easiest way is just multiply the denominator by all the terms there. Though it may give a larger value, but doesn't stop the actual solution. So how many 5 can we see in 15? That is 3. Then that will now be what? 3 times 52, and this will give us 156, right? Minus 3 in 15, that is 5. Then 5 times 20, that will give us what? 100. This will give us 100 plus 1 in 15, that's 15. Then 15 times 3, and this one will give us what? 40, what? 45. So the next thing is for us to add all this. So we have 156 minus 100, and that will give us 56. Then 56 plus 45, that will give us 101. So this will give us 101 divided by what? 15, right? But if you look at this is an improper fraction. And so how do we now determine the proper the mixed fraction equivalent? How many 15 can we see in 101. There is a checklist that we can use in determining this. How do I know? You can say 15 times 1, that is 15. Then 15 times 2, that will give us 30. 15 times 2, that's 30. Then 15 times 3, that will give us 45. Then 15 times 4, 15 times 4, that will give us 60. So obviously, if 15 times 2 give us 30, 15 times 4 give us 60, then 15 times 6, 15 times 6, right, would give us 90, right? So 90. So now, so if you look at it, that implies that 15 can only go in 6 places, because the only addition we can add to 90 that will give us 101 is what? 11, and that is not up to 15. So how many 15 can we say in 101? That is 6 whole number. Then what is the remainder? The remainder will be what? 11. That will be 11 over what? Over what? 15. So that implies that 101 over 15 is the same thing as 6 whole number, 11 over 15. I want to believe this video has helped someone. Thank you for watching, and see you in the next video. Bye bye.